Hello everyone. Welcome to PW. Good evening everyone. Please let me know by writing in the comment section whether audio and video everything is perfect or not. So now we are on 11th lecture of digital electronics and today I am going to discuss digital registers. So please let me know by writing in the comment section whether audio and video everything is perfect or not. So this is very important for electrical electronics as well as for the instrumentation students and computer science and information technology students. So please let me know by writing in the comment section whether audio and video everything is going perfect. Great. Great. So see, first of all, connect on my Telegram so that you will have the updates of all the upcoming classes. Okay. Digital classes already there. You can get all the notes and all. That is Varun sir PW. I will show the QR code ahead. Please observe first. What is the topic that I am going to cover today? If someone want to get all the notes now, so I'm just giving a very basic thing. You can connect on this Telegram group, and this Telegram group, if you join this Telegram group, you can connect directly to me for your all notes and any kind of questions based on the digital electronics. So our today's target is to complete registers. All of you are ready for the registers now? Great. Perfect, sir. Great. Thank you, Betaji. Now please observe registers. You need not to note down everything. Be focused and note all the important points only. Okay. So now please observe. The first is registers. See, what is the basic difference between the register and a flip-flop? A flip-flop can store only one bit data, but in actual practice, we have to store group of bits we need to store. So in order to store group of bits, we need multiple flip-flops. Is it okay? And those flip-flops can be either connected in series or parallel depending upon our requirement of shift or storage. So that particular device which is going to use to store the group of data by using flip-flops are said to be a registers. In simple, what is the purpose of your register? To note down or to store something. Same is for the digital register as well. A digital register is used to store the data, or you can say any information, whatever you want in a digital format, you can store in the registers. So please observe first. Flip-flops are used to store one bit binary data only, hence to store multiple bits. Hence to store multiple bit data, multiple flip-flops are required. To store n bit data, n number of flip-flops need to be connected. Is it okay? Yes, sir. Register is a device used to store multiple bit data. It is a group of flip-flops connected in series or parallel used to store multiple bit of the binary data. So same thing I have repeated 3 times in the 3 different lines. Registers are used to store group of bit. Only that you have to mention. Now, to shift the information stored within the registers, shift operations are needed. To shift the information stored within the register, shift operations are needed. The data can be entered or retrieved in serial or in parallel form. It means one bit at a time, or in parallel means all the bits together at the same time. Is it okay? So if I just conclude what is the entire page information, so only one information, you can conclude this as to store number of bits we need a digital register, and a digital register uses n bit digital register uses n flip-flops. Is it okay? Maybe if you have a bidirectional registers, they may have 2n flip-flops, and in case of universal registers, the number of flip-flops are different. Is it okay? But in general, if we talk about minimum, so to store n bit, minimum n flip-flops are required. Is it okay? Great, sir. Now let's talk about type of shift resistors. Before going to type of shift resistors, let us talk about what is a shift right and shift left resistor. So shift resistor, it is a group of flip-flops used to store multiple bit of binary data, again a repeated line only. The binary information stored in such a resistor can made to move within the resistor. In or out of the resistor can be done by applying clock pulses. So by using clock pulses, we can shift the data, we can retrieve the data, or we can store the data. Is it okay? An n-bit shift resistor can be constructed by connecting n-bit shift resistor can be constructed by connecting n flip-flops where each flip-flop store only 1 bit. Is it okay? So you have to remember this point. An n-bit shift resistor can be constructed by connecting n number of flip-flops where each flip-flop store 1 bit data. Is it okay? Hoping now you are able to remember this line forever. Now the resistor that shifts the bit towards left is called left shift resistor, and the resistors which shifts bit towards right is called right shift resistor. Very like it's a very basic thing. Anyone can understand what is the meaning of left shift resistor. If you understand, the purpose of shift resistor is to shift the data 1 bit. So if the data is shifting to left, it is a left shift resistor. If the data is shifting to right, it is a right shift resistor. Is it okay? Very easy. Great, sir. Now let's talk about what are the different types of resistors that we need to study. Okay. So if we talk about types of resistors, then resistors are classified into 4 types. Resistors are classified into 4 types. Resistors are classified into 4 types. First one is your serial in, serial out resistor, where the data in as well as data out both are in serial format. Is it okay? Yes, sir. Also called as temporary to temporary code converter circuit. Serial in, serial out. Next is your serial in, parallel out resistor, also called as temporary to special code converter. Okay. Yes, sir. SIPO, serial in, parallel out. Very easy to remember. SIPO. First one is SISO, second one is SIPO. Next one is PISO, parallel in, serial out. Special to temporary code. Sir, I want to ask okay, Sai Kumar, I think you are asking this the same question third time, huh? Beta, are you connected with me on Telegram? So just do one thing today, just after the class, na, do a call on the Telegram. Okay, we will do the conversation on call as well, so that I can understand your problem. But what you are asking now, I can just explain to every student. See, mostly student thinks that I am easily able to understand the concept. I am making the notes as well. But while approaching towards the problem, I feel difficult. Okay. Is it true? Yes, sir. It is not only for you, Betaji. This is true for every student whosoever is preparing for GATE. You can't directly get very confident towards the questions. You can opt one approach. First, read your lecture, okay? Then whatever notes you are making, go through that notes and then go with the PYQs first. By solving PYQs, maybe you will not able to solve directly, but you can approach the solution. You can watch the solution. You will be easily able to understand the solution if you have covered the lecture, okay? So after 1, 2, 3, 4, In the worst case scenario, after 10 questions, you will find that there is a connectivity or how to connect the particular concept to particular question, how to solve a particular question and approach towards that question. Is it okay? So from 11th question onward, on the same topic, you will become very comfortable to solve. Is it okay? The basic, because if you are learning after a particular gap, say 2 or 3 years of gap from the study, or you have not covered this particular subject in your BTech, or you have just started in your BTech, okay, then it would take time to absorb, because definitely it's a very high diet, na? So it will take some time. It will take some time to absorb. And how to get absorbed fastly? When you are revising it multiple times and doing the problems based on the concept multiple times. Is it okay? Great. Now please observe here. Come back to this parallel in serial out resistor PISO. Let's talk about PISO. Sir, is there any other resistors as well? Yes, two more resistors. One is called as bidirectional shift resistor, where the shift can be done either in left or in right. They can be designed either in left or in right. Is it okay? And there is one resistor, if you observe, this is a only storage resistor, not a shift resistor. So PIPO, parallel in, parallel out. PIPO, this is wrong, kindly correct it. PIPO. It is just copied, so kindly correct it. PIPO, parallel in, parallel out. Parallel in, parallel out resistor is the only resistor which is not a shift resistor. See, while I have made a correction now, it will take more space in your mind. Something is wrong. Sir did the correction. So that you are going to remember forever, because it happens twice. Is it okay? Same, you will get the benefit if you are going with the multiple revisions. Okay, I'm not saying that first write wrong and then do the correction, but if you give some time, then it will be always with you. Now you are never going to be forget that PIPO is a only storage resistor. All other are shift resistor. This is only a storage resistor. There is no shift operation in, parallel out resistor. Shift operation requires at least either serial in or serial out. Is it okay? Great, sir. Two more special resistors we have. One is called as a bidirectional resistor, and other one is called as a universal resistor. In universal resistor, you can hold the data, you can shift the data, you can store the data, or you can do the serial in, serial out in the bidirectional. It means you can do left or right. Is it okay? So that is a universal resistor. Mostly in our CPUs, we use universal resistor. Is it okay? Great, sir. Now let's talk about first serial in, serial out resistor. Serial in, serial out resistor. Okay, great. Now please observe serial in, serial out resistor. In order to understand serial in, serial out resistor, let us first consider a serial in, serial out resistor 4-bit by using JK flip-flop. So we need to use 4 identical JK flip-flops. First, second, let me make it a little bit smaller. First, second, third, and 4. Okay. So we are using JK flip-flop. Yes, sir. J, K, Q, Q bar. 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 Is it okay? Yes, sir. In shift resistor, until unless we defined MSB or LSB, you can't identify by your own which one is MSB and which one is LSB. Is it okay? So the reason behind is all the flip-flops are connected with the same clock pulse. So you can't identify which one is MSB or which one is LSB until unless designer will let you know about the MSB and LSB. Is it okay? Yes, sir. As all the flip-flops are connected with the same clock pulse. Up to this part, everything is clear? Yes, sir. Now, please observe here. Suppose I am interested to design a shift right resistor. Okay, so if I am interested to design a shift right resistor, then the first resistor in which data is coming in, okay, that I am representing as 3. Okay, and the input to next flip-flop is the output of previous flip-flop. That I am indicating as a next significant, and accordingly we will reach to the least significant bit. How many of you able to understand, beta ji? Please let me know by writing in the comment section. Great, sir. In case of serial in, wherever we are giving the data in, that is going to be the MSB. In case if I am designing a shift right resistor. For a moment, suppose I am interested to design a shift left resistor. So then I will give the data here, and output of this is connected with the input to this. Output of this is connected to the input of this. Output of this is connected to the input of this. Then the data is going to shift onto the left side. Presently, I am making a shift right resistor. Hoping all of you are able to understand. Great. Now, please observe. Whatever data we are going to apply, we are going to give on only one port, that is your J3 port. Is it okay? Yes, sir. Whatever data we want to store, that we are going to give onto the J3 port, and there is a NOT gate for K3 port. Is it okay? Yes, sir. And whatever data we want to take as a out of the data or retrieval of the data from the register can only done through one output port, that is your Q0 port. Suppose if we have a data x3, x2, x1, x0. Suppose if we have a data x3, x2, x1, x0 as 1, or let me draw one more figure and then I will explain. Can you please tell me about the D flip-flop? Yes, sir. All of you are able to see by using D flip-flop. Can I make a D flip-flop from the JK flip-flop? In the last lecture, we have studied how to do the conversion of one flip-flop to another flip-flop, or how to design a desired flip-flop. So if we talk about D flip-flop by using JK flip-flop, in the conversion we have seen J is equals to D and K is equals to D bar. So can you observe this flip-flop as a D flip-flop? Yes, sir. Okay, what you can observe here? Please see, beta ji, what you have observed here. Sir, we are able to observe this flip-flop as the input is Q3. So you can say Q3 complement onto the K2. So this is also acting as a D flip-flop. Sir, even if you observe here, this is Q2 and Q2 complement is going onto the K1. Q2 complement is going onto the K1. So this also looks like a D flip-flop. This also operating, it is operating same as the D flip-flop. Is it okay? So can I use, sir, beginners follow course? Yes, of course, beta. This is for the beginners as well. See, this is your 11th lecture, and I am started with this series is started with first lecture. So if any one of you are new on the channel, you can just observe in the channel live sections. You will get the playlist, or you will get all the classes from lecture 1 to lecture number this. Is it okay? So for that, you have just to click on the symbol represented as Gate Wallah English. If you click, you will reach to the channel, and from there you can go to the live section. Is it okay? In the live section, if you scroll down, you will get the series, all the subjects of the series, okay, in this particular series. And you can follow from the first class if you are from first year or second year or third year, okay. If you have already studied one time, then you can start watching from any of the part. If you are covered the particular portion in your BTech, then also you can start from any of the part. Is it okay? We'll discuss about the short notes and revision notes, beta ji, in the last. Let me cover the particular topic first. Now, please observe. Sir, I am able to connect the particular concept that we may represent 4-bit SIPO, SISO by using D flip-flop, So if we are using D flip-flop, then D, Q, Q bar, of course this is your D3, Q3, Q3 bar, and then again we have a D flip-flop, 1, 2, 3, 4. So can I represent like this? Please let me know by writing in the comment section. Is there any difference? Is there any difference in the previous circuit and this circuit? D2, Q2, Q2 bar, D1, Q1, Q1 complement, D0, Q0, Q0 complement. All the flip-flops are connected with the same clock pulse. So these two circuits are absolutely same. Yes, sir. However, if we use a JK flip-flop instead of D flip-flop, our circuit will be more faster, because we all know that if D is designed with JK, we are just increasing one more NOT gate delay everywhere. If we use a JK flip-flop, the delay will be lower. So generally we prefer to go with a JK flip-flop. However, one can design a D flip-flop from SR flip-flop that will have a delay lower than your JK flip-flop. Is it okay? And then also you can do the implementation. How many of you able to understand up to this part? Please let me know by writing in the comment section, beta ji. Please see, the input serial in is given to the D3 and output we are going to take at this particular port, that is serial out. It means in case if n number of JK flip-flops are cascaded as the outputs of JK flip-flop connected to the input of the flip-flop, then it seems similar to n number of D flip-flops are cascaded. How many of you able to understand up to this part, beta ji? Great. For D flip-flop, we all know the truth table. In case of D flip-flop, whatever input you are going to give, same you will get at the output on application of the clock, because D flip-flop is a transparent latch. We all know about the truth table of D flip-flop. Yes, sir. In a D flip-flop, if we apply 0, the 0 is going to be stored. If we apply 1, 1 is going to be stored on application of the clock as per the truth table. Now please observe, let us suppose for a moment we have a data x3, x2, x1, x0 as 1, 1, 0, 1, and we want to store onto the register. So I have a digital register, like a physical register, you are doing the note down. In the same way, we have a digital register. I want to register this particular data onto the digital register. So digital register will have a storage onto Q3, Q2, Q1 and Q0. Is it okay? Initially, before applying any clock pulse, initially we can make the resistor empty, or you can say the resistors are resetted to 0, 0, 0. Now, the data applied to D3 is this X0 first. When the data applied to D3 is X0, data applied to D2 is the same as Q3, data applied to D2 is 0, that is Q3, data applied to D1 is Q2, that is 0, data applied to D0, Q1, that is 0, data applied to D0, D1, D2 and D3, now we know. To solve any question based on the sequential circuit, we have a thumb rule. It is called as Varun sir thumb rule, okay? Before applying clock pulse, first find inputs to all flip-flops. Then apply clock pulse and follow the truth table. Only if you follow these two things, before applying clock pulse, first find input to the flip-flop, Then apply clock pulse and follow the truth table. Is it okay? You can solve any question based on the sequential circuits. Now please observe. Before applying first clock pulse, first find input to all flip-flops. So what is the input to D3? We know input to D3 is logic level 1. That is X0. Input to D2 is whatever data we have at Q3. Presently we have the data 0, 0, 0, 0. Okay, all the register is empty. Now you are going to give 1 onto the D3. Before applying first clock pulse, D3 input is 1, D2 input is a 0, D1 input is a 0, D0 input is a 0. D flip-flop is a transparent latch. Whatever input you will apply on application of the clock, same appear onto the your flip-flop. Okay, onto your flip-flop. Yes, sir, onto your flip-flop latch. So if you observe here, on application of the first clock pulse, this 1 get stored in the latch Q3, and this 0 is being transferred. This 0 is the input to D2, which will take this position, and this orange 0 is onto the D1, so that will take Q1 latch position, and the input to D0 is Q1, so that will take the latch position of Q0. Is it okay? So on application of the first clock pulse, what happened? Sir, this data is being stored in the latch D3, and Q3 data is shifted to Q2 as the input to D2 is 0. So that is shifted to Q2. Q2 data is shifted to Q1, and Q1 data is shifted to Q0. How many of you now able to understand, beta ji? In the same way, before applying second clock pulse, first find input to the flip-flop. So what is the input to D3 now? Input to D3 now become 0. So this 0 will take this data. 1 is at Q3, and Q3 is same as the data appear to D2. So this 1 will be transferred here. This 0 will be transferred here. This 0 will be shifted here. How many of you able to understand, beta ji? Now before applying third clock pulse, this X2 is now appear onto the D3. Q3 is a 0 which appears onto the D2, and Q2 is 1 which appeared onto the D1, and Q1 is a 0 which appeared onto the D0. So on application of the clock, data appeared after third clock pulse is 1 0 1 0 in the register. What is the data after fourth clock pulse? On fourth clock pulse, this X3 will take the position of Q3, get stored in the flip-flop Q3, and this 1 at Q3 is the input to D2 is stored at Q2. This 0 is shifted here, 1 is shifted here. So for a 4-bit data, how many clock pulses are needed to register the data? For a 4-bit data, how many clock pulses needed to register the data? Sir, only 4 clock pulses are needed for serial in. It means 4 clock pulses are needed to register the data. How many of you able to understand, beta ji? Great, sir. Also, we have to retrieve the data. Can you tell me how many clock pulses are needed to retrieve the data? After fourth clock pulse, what is the data available? Sir, the data available is 1 1 0 1. Is it okay? Yes, sir. So after 4 clock pulses, you have a data. After 4 clock pulses, you have a data appear onto the flip-flop is, after 4 clock pulses, your registers get loaded with the data 1 1 0 1. Now this one is already available at the output port, so you need not to apply any clock pulse. It is already at Q0. You can just take it. However, in order to get Q1 data at this particular port, which I have indicated with the green color, we need 1 clock pulse to shift the data. In the same way, the data at Q2 need to be shifted to Q0 to retrieve the data, and the data at Q3 need to be retrieved. In one clock pulse it reaches to Q2, in other clock pulse it reaches to Q1, in other clock pulse it reaches to Q0. So in 3 clock pulses you will get Q3 data onto the output port. So can you tell me, if we have n bit shift register, serial in, serial out, then how many clock pulses are needed to store the data? Sir, n clock pulses. For 4-bit we need 4 clock pulses. And how many clock pulses are needed to retrieve the data from the register? N minus 1. Why n minus 1? Because one data Q0 is already available. Rest you have to do the shift operation. So n minus 1 clock pulses are needed to retrieve the data. How many of you able to understand this perfectly? Please let me know by writing the comment section, beta ji. So what observation we have seen? To register 4-bit input data from MSB, 4 number of input clock pulses are required. However, to register n-bit data from the MSB, n number of clock pulses are required. For retrieving 4-bit data, 3 clock pulses are required, and for retrieving n-bit data, n minus 1 clock pulses are required. So I am just making it very small. You can say, sir, one note point for serial in. How many clock pulses are required? For n-bit data, serial in requires n clock pulses and serial out requires n minus 1 clock. How many of you able to understand? Please let me know up to this part. Great, sir. So always remember, for any serial in register we required n clock pulses, for serial out we required n minus 1 clock pulses. How many of you able to understand? Please let me know by writing in the comment section, beta ji. How many of you able to understand up to this part? Great. Now let's move to the next one, that is your serial in, parallel out shift register. Serial in, parallel out shift register. Serial in, parallel out shift register. Hoping all of you able to understand serial in, serial out. So how many number of clock pulses are required for serial in? N. To retrieve n minus 1, because 1 is already available at the output. Okay. Yes, sir. Now, if we talk about serial in, parallel out, also referred as SIPO register. So let's talk about 4-bit SIPO register. In this we have serial in the same way as we have observed for serial in, serial out. But here the data out gets changed. Now please observe, we can either use JK or D flip-flop. For shift register we prefer to use JK flip-flop because to reduce the delay, and we are not using SR flip-flop in design. The reason behind is invalid state. Okay, so we always prefer to go with a JK flip-flop instead of going with the D flip-flop. However, if you want, you can go with D or JK. It would be easy to understand with the D, so I am just making a D flip-flop. Please observe, beta ji. D2, Q2, Q2 bar, D1, Q1, Q1 bar, D0, Q0, Q0 bar. All of you can now see why it is called as shift register, because the input to D2 is Q3. So whatever data is at Q3, that is going to be shifted to Q2. In the same way, whatever data is onto the Q2, it is going to shift it to Q1, and whatever data is on Q1 is input to D0, so that data is going to shift it to Q0. So ultimately the data is being shifted one by one bit. That is why it is called as shift register. The data is shifting onto the right side, so we called it as shift right register. Is it okay? Yes, sir. In shift registers, all the flip-flops are connected with the same clock. Clock acts as a circuit activation, we all know. So all the flip-flops are connected with the same clock, so all get activated at the same time. All get activated at the same time. We have only one port for serial in. So we have to apply the input data which we want to store here one by one bit. Is it okay? However, it is a serial in parallel out. So it means whatever data is available onto the register can be taken out at the same time. So this is a parallel out. Okay. Yes, sir. Can you tell me how many number of clock pulses are needed for serial in? So you can say, sir, for serial in, n clock pulses are required. However, for parallel out, how many clock pulses are required? 0. Because already whatever data is onto the Q3, Q2, Q1, Q0, you can just take out. If you give clock, the data gets changed. So that is why we say temporal data, because in every clock pulse the data gets changed. So that is a temporal data to a special code. So it also acts as a temporal code to a special code converter circuit. How many of you now able to understand, beta ji? Can you please tell me by writing in the comment section, are you able to understand SIPO register now? Great. Let's try to understand what kind of question gate design from this particular topic. Let us first get started with this one. I need your response in the comment section, beta ji. If no one is responding, how would I know? So, please observe this question. Please observe this question and try to answer in the comment. A 4-bit SIPO shift register. I will guide you first question. Please observe. SIPO shift register is used with a feedback as shown in figure below. Shifting sequence is Q3, Q2, Q1, Q0. It indicates the data is shifted from Q3 to Q2, Q2 to Q1, Q1 to Q0. If the register is initially loaded with a bit pattern 1011, then the pattern which will be loaded into the register after 51st clock pulse will be. You have to find the data in the register after 51 clock pulses. Is it okay? Yes, sir. Now, please observe. Most of the gate question or your other exams, competitive exam questions asked from the particular topic, that is SIPO only. And the reason behind is SIPO, a kind of SIPO can be used to design your famous ring counter or a Johnson ring counter. Okay. They are also a kind of resistors which can designed as a counters, which will have a lot of functions in controlling the motors, like stepper motors in the automation industries. So it's very important. Your shift resistor will become very important. Okay. Now please observe this question. In this question, we have a resistor. Instead of designing 4D flip-flop or 4JK flip-flop with all the outputs get connected, they have just shown a 4 boxes. So now we know the internal circuitry. This internal circuitry is SIPO. SIPO is like this only. Is it okay? And their outputs are taken with the logic gates. They have again fed back. This input is indicating clock. We all can understand the same clock is applied to all flip-flop in the resistor. And this is your D3, input to D3. Input to D2 is Q3, input to D1 is Q1, input to D0 is Q0. Is it okay? Yes, sir. So we all can see that this is a XOR gate. We all can see that this is a XOR gate. And we all can see this is also a XOR gate. So one can easily say, sir, what we are getting? We are getting Q1 XOR Q0. Since XOR gate follows commutative and associative law, so we can say the input is Q2 XOR Q1 XOR Q0. Is it okay? We all know about XOR gate. One very important point. XOR gate is a odd number of ones detector circuit for 3-bit. 3-bit XOR gate is a odd number of ones detector circuit. Whenever the number of ones in an input is odd, XOR gate will give output logic 1. Yes, sir. So I'm going to use that information and also observe how on the different clock pulses data stored in the register is going to change. Now please observe, Betaji. Before applying clock pulse, first find input to the flip-flop. So we all can understand what is the input to the flip-flop. Input to D3. Input to D3 is Q2 XOR Q1 XOR Q0, and input to D2 is Q2. Input to D1 is Q1, and input to D0 is, okay, kindly do the correction, Betaji. This is Q3, this is Q2, and this is Q1. Okay, yes, great. We all remember about the D flip-flop truth table also, sir. I am just constructing that truth table in a rough portion with the clock D and output next state Qn plus 1. Clock D and Qn plus 1, that is next state. If there is no clock, irrespective of the data at the input, it will remain in the previous state called Qn. In case if the clock is high, then depending upon the data applied to D, the next state will become 0 or 1. Because D flip-flop is a transparent latch. If you apply 0, you will get 0. If you apply 1, you will get 1. But after applying the clock pulse, if you are not applying any clock pulse, the data will remain in the previous only. Since all the flip-flops are connected to the same clock pulse, it means all are going to be activated at the same time, and depending to their input, they are going to give the they are going to store the particular output. Okay, yes, sir. Now please observe here. We have to identify the data after 51st clock pulse. Let's try to identify the possible repetition. Okay, and for that I am just using one clock here. Then we have a data Q3, Q2, Q1 and Q0. Now before applying clock pulse, 0th clock pulse is before applying clock pulse. Before applying clock pulse, what is the data with which register loaded? So register was initially loaded with the data 1011 as per the given question, 1011. Now when you apply the clock pulses, what happened? What happened after first clock? Please observe, Betaji. You have to observe these three. If in these three number of ones is an odd number, then Q3 will become logic 1 because D3 is logic 1. In case if number of ones is even, then 0 is applying onto the D3, so 0 get stored onto the Q3. So if you are observing here, I am doing Q2 XOR Q1 XOR Q0. Number of ones is a even, so 0 get stored here. This is going to be shifted here. This is going to be shifted here. This is going to be shifted here. After first clock pulse, the data in the register would become 0, 1, 0, 1. After second clock pulse, here again, if you observe these three, now these three XOR is the input to D3. And XOR gate, we all know for a 3-bit XOR gate output is logic 1 whenever the number of ones in an input is an odd number. So you can observe here, the number of ones in an input is an even number. So what you will get? You will get 1 here. No, sir, we will get 0 because even. Yes, and this 0 is get shifted here, 1 is get shifted here, 0 is get shifted here. Now observe what happened after third clock pulse. Again, before applying third clock pulse, I am finding out the input to all flip-flops. If you observe these three, that is your Q2, Q1 and Q0. Number of ones in Q2, Q1 and Q0 is an odd number. So XOR of Q2, Q1 and Q0 will become 1. Input to D2 is Q3. So Q3 data is shifted here because D flip-flop is a transparent latch. We all can see. This is going to be shifted here and this is going to be shifted here. So data after third clock pulse. Similarly, data after fourth clock pulse, we all can see odd 1, 1, 0, 0. After fifth clock pulse, again odd, 1, 1, 1, 0. After sixth clock pulse, what happened? Sir, again it's even, 0, 1, 1, 1. Then odd means on seventh clock pulse, 1, 0, 1, 1. Array sir, we are now getting the same data as available onto the 0th clock pulse. So we are getting now the same data as available onto the 0th clock pulse. It means on every 7th clock pulse, the data in the register is same as the 0th clock pulse. So on 49th clock pulse, the data will remain same. Is it okay? On 49th clock, the data will remain same. Yes, sir. 49, 50, 51, 52. So we need to find out the data in the register after 51 clock pulses. So we all can see what is the data available after 51 clock pulses. How many of you able to understand this? Beta ji, please let me know by writing in the comment section. So what is your answer? 0, 0, 1, 0. How many of you able to understand up to this part? 0, 0, 0, 0, 1, 0, 0, 1, 0. How many of you able to understand, beta ji? Sir, IIT Madras, tough level or easy level for double E? See, first thing is, don't imagine like if a particular IIT is going to frame a question, is going to conduct an exam, then they are the only one responsible to design all the questions and everything. Okay, there are multiple channels are there from which the question papers are collected. Okay, so do not get in search with those kind of things from where the questions are being collected. Let's try to approach that particular professor. Please don't do that. Okay, so I'm just telling you there are multiple different professors from them the questions are collected. Even they don't know what questions are going to be shuffled and how the particular questions are going to be framed. Is it okay? So that particular questions among them, which particular questions are being selected in the paper, that is purely random thing. Okay, no one knows. Only one or two people knows that what that random process will done, and then finally that paper will come. So never thought that professors in the particular IITs are only going to discuss everything. Rest of the IITs are not participating in all. Okay, so forget about which IIT is going to create. For your one thing about what we have seen, that whenever let us suppose if the chance given to me, I will see what are the previous year legacy of the questions created by the different by IIT Madras only. If this year going to be conducted, then I will create in the same way, in the same manner. Somehow I get biased with the PYQ. Is it okay? So for that you can go with the PYQ and check what particular topics have given more weightages. Okay, and accordingly you can do the preparation. There is no, but don't be rely only on that. It is an additional part that you can do. Okay, now please come back to this. How many of you able to understand this question, beta ji? Can you answer this now? Can you answer this question now? It's a similar kind of question. Can you answer now? Can you answer now? Can you answer now? Instead of using XOR, we are using XNOR. And this XNOR gate is created like this. So can you answer? Initially, a 4-bit SIPO shift register is used to feedback as shown in the figure below, shifting sequences Q3, Q2, Q1, Q0. If the output is initially 0, 0, 0, 0, the number of clock pulses after which the output will repeat itself is. So again, you have to tell after how many clock pulses the repetition goes on. Is it okay? The same we did in the last question as well. There they have asked 51, 112. So accordingly, we will see after how many clock pulses it get repeated, and then we can find out. Is it okay? Yes, sir. If we talk about this, after how many clock pulses the same data would appear? So initially, what is your data? Initially, what is your data on the 0th clock pulse? So I am creating a clock here. We have a Q3, Q2, Q1 and Q0. So initially on the 0th clock pulse, we have a data 0, 0, 0, 0. And we are using Q3 XNOR Q0. We are using D3 as Q3 XNOR Q0 and D2 as Q3 and D1 as Q2 and D0 as Q1. So before applying the clock pulse, first find input to the flip-flop. Now we know about the input to the flip-flop. Now apply the clock pulse and follow the truth table of the flip-flop. Since we know in case of shift register, either it can be designed by using JK or D flip-flop, it will act only with a shifting date operation, and the shifting operation is already mentioned in the question as well. It's a shift right register. So now on application of the first clock pulse, what happened? Only we have to follow the feedback, rest all are going to be shifted. So from the feedback we have Q3, Q0. We all know XNOR gate is a equivalence detector. So whenever the inputs are equal, then only XNOR gate will give logic 1, otherwise it will give logic 0. So Q3 and Q0 both are 0, 0, so it will give logic 1. This 0 is shifted here, this 0 is shifted here, this 0 is shifted here. Again observe your Q3 and Q0. So if you observe Q3 and Q0, now they are 0, 1, different. For different, what we will get? For different, we get 0. For same, we get 1. For different, we get 0. XNOR gate is a equivalence detector. On third clock pulse, what happened? 1, 0, 1, 0. Then on fourth clock pulse, what happened? So on fourth clock pulse, again we get 0, 1, 0, 1. On fifth clock pulse, what we get? 0, 0, 1, 0. Is it okay? On sixth clock pulse, what we get? 0, 0, 0, 1, 0, 0, 1. On seventh clock pulse, what we get? 1, 1, 0, 0. On eighth clock pulse, what we get? 0, 1, 1, 0. So on ninth clock pulse, what we get? It goes ahead. How many of you able to understand? On the first clock pulse, same 1, same different 0, same 1. Yes, then again different 0, different 0, same 1, same 1, different 0. Okay. So on the 8th clock pulse, we are getting 0, 1, 1, 0. What happens to the 9th clock pulse, Betaji? On the 8th clock pulse, we are getting 0, 1, 1, 0. 0, 1, 1, 0. On the 9th clock pulse, what we get? 1, 0. On the 8th clock pulse, we are getting this 1, 0, 1, 1. Okay. Yes, sir. On the 10th clock pulse, what we get? Sir, 1, 1, 0, 1. On the 11th clock pulse, what we get? 1, 1, 1, 1 will become 1, 1, 1, 0. On 12th clock pulse, what we get? 0, 1, 1, 1. On 13th clock pulse, we get 0, 0, 1, 1. On 14th clock pulse, we get different. So 0, 0, 0, 1. On 15th clock pulse, we get 0, 0, 0, 0. So it would act as a 15 clock pulses is required to have 0, 0, 0, 0 data. How many of you able to understand, Betaji? Son, in fourth, 0 is converted into 1. In fourth, no, Betaji, please observe here. On the first clock pulse, these two are same. Okay. So this will become logic level 1. It's being shifted here, it's being shifted here, it's being shifted here. No doubt. In the second clock pulse, observe this and this. Before applying second clock pulse, XNOR of these two. Different will give logic level 0. This is shifted here, this is shifted here, this is shifted here. Now, on the second, before applying third clock pulse, observe Q3 and Q0, because Q3 and Q0 XNOR will give you logic. So they are same, so you will get logic level 1. The 0 is shifted, 1 is shifted, 0 is shifted. Now observe on the fourth clock what happened. These two are different, so you will get 0, 1, 0, 1. Beta ji, fourth I have suggested you once again. So hoping all of you able to understand. Before applying clock pulse, first find input to the flip-flop. Always remember, before applying clock pulse, repeat this line as many times as possible. Before applying clock pulse, first find input to the flip-flop, apply clock pulse and follow the truth table. Is it okay, beta ji? Great. Now please observe. Can you now solve any question based on the serial in parallel out? Can you now solve any question based on the serial in parallel out? So I am giving one question to you as a homework, and try to solve this question, and after solving this question, post your question onto the Telegram, where you can just ping me. Kindly check the solution, sir. Okay. So you can ping me. Kindly check the solution, sir. Just do the scan. You directly connected to the Telegram, Varun sir, PW. Okay. Great. Now I am moving towards the next. That is your one more. Let me complete the topic first, and then lastly we will again discuss one more question based on the serial in parallel out. Okay, it's a different kind. Can you tell me parallel in serial out shift resistor? Parallel in serial out. Till now we have completed two. Parallel, serial in serial out, serial in parallel out. Now let us discuss about parallel in serial out resistor. Parallel in serial out resistor is special to temporal code resistor. So again I am considering 4-bit. So for 4-bit we need 4 flip-flops. For 4-bit we need 4 flip-flops. Yes, sir. In this we have to use one more circuit called multiplexer. In this we need to use one more circuit called multiplexer. We all know about the multiplexer. Multiplexer will provide the output based upon the select. So these multiplexers, all multiplexers used here are of 2 cross 1 with the I0 and I1 pin, I0 and I1 pin, 2 cross 1 mux, 2 cross 1 mux with the I0 and I1 pin. Hoping all of you are remembering about the multiplexer. Yes, sir. We have D3, Q3, Q3 complement. Okay, the data in is from here. We have X3 data, X2 data, X1 data, and X0 data, whatever we want to store in our resistor. Okay, and then I'm using one two cross one multiplexer where Q3 may get connected with D2, Q2 may get connected with D1 depending upon the select, and Q1 may get connected with D0 again depending upon select only. All the select lines are connected with the same input. It means either we can do parallel in or we can do serial out based upon the select. When select S0 When select S0 is equals to 0, data is parallel in, and when S0 is equals to 1, we are getting serial out operation. All flip-flops are connected with the same clock pulse. All flip-flops are connected with the same clock pulse. It means all get activated at the same time. Is it okay? Yes, sir. Now, how to perform this parallel in operation? Please observe everyone. Whenever we have to store or register the data in this particular digital register, suppose we have a data x3, x2, x1, x0, then first we select S0 equals to logic level 0. When S0 is 0, I0 pin got connected. I0 pin got connected to Y. This is going to be connected to Y, and this is going to be connected. So now we know about the inputs to all flip-flop. D0 is x0, D1 is x1, D2 is x2, and D3 is x3 if we have parallel in, that is S0 is equals to 0. When we give one clock pulse, the data get stored in the latches of the flip-flop Q3, Q2, Q1, Q0 get stored with the data on x3, x2, x1, x0. So only one clock is required. Only one clock is required for parallel in operation. So for n bit parallel in, only one clock is required. It is very easy to store the data. It is very easy to store the data. It is very fast to store the data. Now let's talk about retrieval. We are getting retrieval at S0 pin. Is it okay? So at Q0 pin. So at Q0 pin, if we are taking the retrieval, then for retrieval, first of all, we have to select S0 is equals to 1. Whenever we are going to choose the select one, what happens, sir? When select one, I1 get connected here, this will get connected here, and this will get connected here. So what happens, sir? Whenever we are going to provide a clock, the data at Q3 being shifted to Q1, Q1 being shifted to Q1, Q2 being shifted to Q1, and Q1 being shifted to Q0. How many of you able to understand? Q0 data is already available at the output port, but we need to shift this data. It required one clock pulse. We need to shift this data. In one clock pulse, it will reach here. In another clock pulse, it will reach here. In the next clock pulse, it will reach here. So how many clock pulses are needed for a 3-bit? Sir, for a 4-bit, 3 clock pulses, because 1 bit is already available. For that, we don't need any clock. But for this, we need clock, because we have only one output position. So how many clock pulses are required for serial out? For serial out, n-1 clocks are required. How many of you able to understand, Betaji? Can you please tell me? Great. Sir, please could you share the fee structure for the batch subscription? Betaji, actually, as a teacher, my prime objective is to just teach you. But I can just give you a source. You can just type in your browser pw.live, or you can download PW app from App Store. Okay. If you are on Android, you can use Play Store. Download the Physics Wallah app, and there you can select your particular exam, that is GATE, your language which you want. If you want English, you can choose English, and you will have all the batches which are already running or upcoming. Okay. So from there you can choose. There are different fee structure and everything will be mentioned there. So from there you can choose. Okay, Betaji? Great. Or you can just, after the lecture, you can just post your query in the comment section also. The team will connect you. Is it okay? PISO is a shift register. Yes, Betaji, PISO is a shift register. Here parallel in, but the output is done with the shifting operation only. So parallel in, serial out is a shift register only. Is it okay? Yes, it is a shift register. Sir, PISO shift register work without a clock? No. no sequential circuit can operate without a clock. It is not possible for any flip-flop to operate without a clock. And the symbol of edge-triggered clock indicates whenever the clock level changes from 0 to 1, yeah, it means during the transition of the clock from low to high. See, the clock symbol is representing it's a edge-triggered. A edge-triggered circuit will operate only during the transition of the clock. The period of transition of the clock is only period where your flip-flop get activated, and you can say depending upon the input, output will available as per the truth table. Is it okay? Is it okay, beta ji? Great. So always remember, no flip-flop can operate without clock. Clock act as a circuit activator. We have already seen in the SR flip-flop, in the flip-flop sections, SR flip-flop, JK flip-flop, D, T, there I have told you everything. It is available in the same, onto the same channel. You can just observe the live lectures in the, when you go to the channel, you have to choose the live sections, and in the live sections, if you scroll down, you will get the previous lectures, okay? Also, you can get the lectures on my Telegram. Now come back to the serial in, parallel in, serial out resistor. Now the last one is your parallel in, parallel out shift resistor. This is not a shift resistor. Intentionally I made this. This is not a shift resistor. Instead of shift, it is the only resistor which is a storage resistor. Can you remember this now onward? Always remember that shift resistor is the only resistor which is a storage resistor. How many of you able to understand up to this part? Great. Now please observe, beta ji, how a parallel in, parallel out resistor will operate. If you observe parallel in, parallel out 4-bit resistor, if you observe parallel in, parallel out 4-bit resistor, you can see it can't work as a shift resistor. And that is why most of the time question asked in your competitive exam, which among the following is not a shift resistor? So it is very easy to remember. And yes, which is going to use as a storage resistor, the fastest storage resistor is your PIPO. That is parallel in, parallel out resistor. There is no shift operation because all of you can see that output of any flip-flop is not connected to the input of the other flip-flop. Here we are getting the data X3, X2, X1, X0. So on application of the clock, the parallel in operation happened. And parallel out operation, you can see Q3, Q2, Q1, Q0. So we have parallel out operation as well. D3, Q3, Q3 complement, D2, Q2, Q2 complement, D1, Q1, Q1 complement, D0, Q0, Q0 complement, and we have a clock. How many of you able to understand, beta ji? Sai Kumar sir. How many of you able to understand up to this part? Is there any doubt up to this part? Then please let me know by writing the comment section, beta ji. Great, great. Great. Up to this part, if there is any doubt, please let me know by writing the comment section, beta ji. Now, can you please tell me what are the What is the time period for parallel in? Parallel in we required. How many clock pulses are required for parallel in? For n bit parallel in required 1 clock. And how many clocks are required for parallel out? 0. 0 clock. So what it indicates? What it indicates, Betaji? It indicates only one clock is required to store n bit data, and 0 clock is required to retrieve the data. So this can act the fastest storage as well as retrieval register. So whenever you have to store the data and retrieve the data, this will be the fastest storage register among all. How many of you able to understand, Betaji? Great. Is there any doubt up to this part? See, there are different purposes of the registers. If we have a purpose of the register is to store the data, we are not in a mode of shifting operation, then we will use a PIPO register, that is parallel in parallel out register, because our objective is to store the data only and retrieve the data only. In case if we have to do the serial to parallel converter as well as storing the data, multiple operations if we need, then we need to go with the shift registers. Is it okay? And one of the greatest use of the shift register is a ring counter. How many of you able to understand? Ring counter will have further multiple uses. Let me show you the application of registers. So these questions are already asked in your previous year. That purpose of register is to temporarily data storage, data transfer between subsystems. Registers are used also for the data transfer in subsystems. Serial to parallel or parallel to serial conversion. Arrow on both sides indicating serial to parallel or parallel to serial conversion. Sequence generation, digital delay implementation, arithmetic shift operation whenever needed, communication interferences, okay, and ring or a Johnson ring counters. Now please observe, Betaji, if you have remember, we have discussed one adder named as serial adder. In a serial adder, only one full adder is used to add group of bits. Have you remembered that? Yes, sir. So if we talk about serial adder, so in a serial adder, only one full adder is used to add group of bits. So here we have one full adder, and we all know about full adder. Yes, sir. And we need two shift registers. These registers are parallel in serial out registers. Basically, these are PISO and PISO. Suppose I am going to design a 4-bit serial adder. Okay. Yes, sir. So their outputs are connected like this. This is your A0, A, B, and we have C as well. For that, we are using one D flip-flop. Okay. Yes, sir. So we have A, B, C. Now it provides some bit, which is nothing but A XOR B XOR C. We all know. And this data is being stored in SIPO. Okay. Yes, sir. And we have a clock. clock. These two are being clocked directly. Yes, sir. And this is being clocked with 1. So basically, if you observe this circuit, it can act as a group adder circuit. This circuit contains just one application of the registers I want to show you. One practical circuit also that we have to discuss. I am taking a consideration of serial adder in this. Now please observe what actually happened here. Suppose if we have a data A3, A2, A1, A0 and we have a data B3, B2, B1, B0 and we want to perform the addition of these two numbers. So first clock, when we apply first clock, all the resistors get activated. Whatever data we have A3, A2, A1, A0 are being parallel in, and B3, B2, B1, B0 are being paralleled in. Now B0, A0 and initial carry, okay, so this is your carry, initial carry onto the flip-flop. After a small delay because of this flip-flop, it get logic 1 after a delay. Is it okay? Yes, sir. Now, after a delay, this flip-flop will work. You can even use a NOT gate instead of using this entire flip-flop. You can use a NOT gate as well. Okay. So after a delay, we get the clock on this as well as on this. So this will give you logic level 1. Let this will operate without delay and this will have operation with the delay. Okay. Yes, sir. So after a clock would appear, what happened? Sir, because we also want that whenever the clock changes, transition would appear on this. Okay. Now it is okay. Please observe. At the time of addition started, A0, B0 and initial carry C0 which is there onto the D because of A0 before applying any clock pulse. Before the addition get started, we have A, B, C all 0, all the registers are resetted. Okay, everything, all the registers and full adders are resetted, outputs of the full adders are resetted. So initial carry 0, that 0 will come here, C0. So we have a C0, A0, B0, C0 and a full adder operation perform, which will give the sum bit and carry bit. So that sum bit, after a delay, a clock would appear here to store that particular sum bit data onto the Q3. Is it okay? Then it goes to Q2 and Q3 will have second data. Because of the addition of these three, second data, we have shifted Q3 to Q2, then Q1 to Q0. So now you can observe Q, Q3, Q2, Q1, Q0, all these 4 bits along with the Q as a carry out bit, we have the addition of a full adder. So this is how a full adder will perform its operation. How many of you able to understand? You can even use a delay circuit. If you will feel difficulty with this, how it would work now? If you feel difficulty with this, how this delay would work, you can use a simple delay circuit as well. You can use a simple delay circuit as well. Is it okay? So this is a delay circuit. You can use a delay flip-flop or you can use a delay circuit. Is it okay? The purpose of delay circuit is, before next addition operated, before next addition done, the data get stored on the flip-flop. Is it okay? And it will done after the addition will perform. So the delay circuit will have a delay required for the addition of the full adder. Is it okay? As well as the shift operation need to be performed here. So if we have 4 bit, for first bit it got shifted, A0 B0 is onto the input AB, and now after 3 clock pulses we reach up to A3 B3. So first clock, second clock, third clock and fourth clock. On fourth clock, post fourth clock, you will have the entire addition. Post fourth clock, you will have the entire addition. So in serial adder, to add n bit data, we required n clock pulses. When we started with the serial adder, I told you that we will discuss serial adder after completion of the shift register. Hoping now you are able to recall that. Great, great. Hoping everyone able to understand up to this part. Great, sir. Can you solve this question now? I haven't discussed yet about anything about the counters and all, but can you solve this? We have a thumb rule. What is the thumb rule? Before applying clock pulse, first find input to the flip-flop, then apply clock pulse and follow the truth table. That is what all we have to do to solve any question. So this question asked in GATE 2014, 2 marks. Let's discuss how to solve this. The output of the two flip-flop Q1, Q0, the output of the two flip-flop, one is Q1, another one is Q2. This is your J2, K2, Q2 complement, Q1 complement, K1, J1. And we all can see what is the input to, what is input to J1. Input to J1 is Q2 bar, and input to K1 is Q2. Is it okay? Yes, sir. We can also see the input to K2 is Q1 complement, and input to J2 is K2. How many of you able to see this? Yes, sir. Can you answer this question? Can you answer this question? Let's observe. See, the output of the two flip-flops Q1, Q2 in the figure shown are initialized 0, 0. Initialized with 0, 0 means initially Q1 and Q2 are 0, 0. The sequence generated at Q1 upon the application of the clock pulses. If we are going to continue to shoot the clock pulses, then what happens with Q1? Is it okay? Yes, sir. Now please observe. How to solve this. So we have a Q2 and Q1. You can take any one of them as a MSB, it doesn't matter. So Q1, Q2 I am considering like this. Before applying clock pulse, first find input to the flip-flop. So we can see J1 is Q2 complement, K1 is Q2, and J2 is Q1, K2 is Q2 complement. Is it okay? Yes, sir. We all remember about the JK flip-flop truth table as well. Yes, sir. In JK flip-flop truth table, we all able to recall the JK flip-flop truth table as well. Yes, sir. What is the JK truth table? Let me show you on the next page, because otherwise this page get filled. We have Q1, Q0, and I am using clock here. Now please observe, beta ji, and I just wanted the answer from everyone. See, we all can see what is J2. What is J2, beta ji? J2 is Q1. J2 is same as Q1. K2 is Q1 complement. J1 is Q2. J1 is Q2 and K1 is J1 is Q1 Q2 complement, and J1 is Q2. Is it okay? That we are getting as the input to the flip-flop. Is it okay? From the circuit I am able to identify. Before applying clock pulse, first find input to the flip-flop, then apply clock pulse and follow the truth table. Even you don't know about the counters or anything about the sequential circuit, you will be able to solve any question. Please observe here. We all know about JK flip-flop truth table. So how a JK flip-flop will behave? 0, 0, 0, 1, 1, 0, 1, 1. Sir, it would behave Qn 0, 1, Qn complement. Is it okay? Yes, sir. Now please observe here. Before applying first clock pulse, we need to find input to the flip-flop. What is the initial condition given? Initialized to 0, 0. It means we have Q1, Q0 as a 0, 0 onto the 0th clock pulse. Before applying first clock pulse, first find input to the flip-flop. How many of you can see that? How many of you can see that these two JK flip-flops are cascaded directly? Is it okay? Yes, sir. We all can see that these two flip-flops are cascaded directly. So whatever data at Q1 is going to be shifted to Q2. There is no doubt in this. Yes, sir. Q1 data is going to be shifted to Q2. There is no doubt in this. Yes, sir. Now please observe, beta ji. Now please observe, beta ji. Can you please tell me what is Q1 0? What is Q2 0? If Q1 and Q2 both are 0, 0, first observe what happens to this Q2 0. If Q2 is 0, its complement is 1. So it means onto the J1 we are getting 1, onto the K1 we are getting 0. 1, 0 is a set. 1, 0 is a set for the JK flip-flop. Yes, sir. And now observe whatever at Q1 is going to be shifted to Q2, because we can see that very similar to the shift register, these two JK flip-flops are being cascaded. So Q1 is shifted to Q2. Is it okay? Yes, sir. Again, please observe what is Q2 0. Q2 0 means this is 1 and this is 0. 1 0 1 0 in the JK flip-flop. So on application of the second clock pulse, you will get 1, and this 1 is being shifted here. Now on application of the third clock pulse, what happened? This 1 means 0 1. 0 1 is a reset condition for the JK flip-flop. So this get resetted. This is 1. On to the fourth clock pulse, what happened? This will be resetted. This will be shifted here. So what is the sequence we are getting for Q1? For Q1, we are getting sequence 0 1 1 0 0, 0 1 1 0 0, 0 1 1 0 0. This is not the option. 0 1 1 0 0. This is not the option. 0 1 1 0 0. This is not the option. 0 1 1 0 0. Yes, sir. Only this satisfies the particular condition. How many of you are able to understand, beta ji? Can you please let me know by writing in the comment section? Moreover, if you observe this circuit, how its circuit is behaving, basically this circuit is similar to, this circuit seems to be similar to this one. We will learn this concept in your ring counter, but before going to ring counter, you will be able to solve the question by using thumb rule. It doesn't matter how much you have read for the sequential circuit. Always you have to remember only two things. Before applying clock pulse, first find input to the flip-flop, apply the clock pulse and follow the truth table. Is it okay? And other, you need to remember about the excitation table, where we have to design our desired sequential circuit. Is it okay? So two things are required. Initial state is given to you. So on the 0th clock pulse, we have 0 0. And on the first clock pulse, what happened? On the first clock pulse, this will become 1 0. On the second clock pulse, this will become 1 1. On the third clock pulse, this will become 0 1, and on the fourth clock pulse, you will get 0 0. So all of you hoping able to understand. So what we are getting, 0 1 1 0 0, 2 times 1 2 times 0. That is only possible. 2 times 1 2 times 0 is in the option number D. Is it okay? Because rest everywhere, if we observe, 2 times 0, 2 times 1, 2 times 0. C also possible, sir. C is also possible. But since initially it is started with 0, na, so only 1 0 they have to show. That is why D seems to be more correct comparative to C. D seems to be more correct comparative to C. As in D, we are getting 0 1 1 0 0. How many of you able to understand up to this part, beta ji? Can you please let me know by writing in the comment section? See, C and D both are correct, no issue. But the issue is with the C is, it is started with 0. It is given that the sequence of the generated with the clock signal is. So instead of C, D seems to be more correct. Okay. 0, 1, 1, 0, again 1, 1, 0 is going to be, it goes on. How many of you now able to understand, Betaji? Great. Hoping you have enjoyed the session so far. I am also just showing you about the important major applications of the registers. Okay. Major applications of the registers. So please observe the major applications of the registers once. Up to this part, is there anything, any issue, Betaji? PIPO is a register, only stores the data performed, no shifting. Why it is included under the families of shift registers in many textbook? Betaji, actually the name given as a shift register, and that is why in many different exams the question asks that shift registers, which of the following is not a shift register? So you can now easily understand why it is not acting as a shift register, because there is no connection of the inputs and outputs where the shift operation can be performed. Is it okay? Is it okay, Betaji? Great. So how many of you able to understand up to this part? Please let me know by writing in the comment section. I have shown you to this as well. Temporary data storage, data transfer, shift operation, serial to parallel conversion, parallel to serial conversion. Data buffering is also one we can use. Memory address storage, where we can use the shift registers, okay, or registers. It is used for the instructions or counters and sequence generation, mostly used in your ring counter and a Johnson ring counter, or a delay element. It can also be used as a delay element. If you are using n numbers of n bit shift registers, let us suppose 5 bit shift registers, and you have serial in, serial out. So basically whatever data you are giving to serial in, same you will get at serial out, but after a delay of 5 clock cycles. Is it okay? So sometimes it is also used as a delay element. How many of you able to understand up to the class completed so far? Great. Hoping you have enjoyed the session. See, in the comment, someone is asking about the metastable state. So we will discuss about the metastable state when we are discussing about the setup and hold time. Okay, it's a kind of unstable state. So we will discuss about that when we are going to discuss about the setup and hold time. Setup and hold time concepts need to be understand first before going with the stable states or unstable states of the counters or registers. Is it okay? Great. So hoping you have able to understand up to the point completed so far. Great. So lots of love. I'm keeping the class up to this part only. Please connect with me on my Telegram for the notes and also for the upcoming lectures. Okay. Also, you can just comment on this your comment section. Would you be able to solve the question now based on the registers or not? First, go with the PYQs of your branch as well as the branches in which the digital subject is common, like CS, IT, your IN, ECE, whatever your branch, EE, whatever your branch, you can take the questions of the other branches as well. So great, lots of love. Thank you, everyone. Good night.